Okay, hello everyone. So welcome to joining our presentation to the paper entitled Yet Another Format of Universal Dependencies in Korean, which was done by me, Igor, and Leah, Yunzhong, Kente, Mieka, Francis, and Chengye. So here's the background of our work. As many of you guys may all know, dependent parsing, which we focus on in this paper, finds the relation between the words in a sentence and try to form a dependency graph that explains the grammatical structure of the sentences. And there has been a lot of works proposed for dependent parsing, and one of the most famous is the Universal Dependencies project, proposed by Leah in 2016 and 2020. So for the Korean language that we focus on, there are two tree banks in the Universal Dependency project, including the GSC tree bank and the KAIST tree bank. And in recent years, there are also quite a lot of dependency parsing models proposed, such as UDPipe and Stanza, and those are frequently used and open to the public that we can do some training on. However, there exists quite a lot of problems for dependent parsing for specifically the Korean language. While dependent parsing has been studied extensively for resource-rich languages such as English, studies trying to improve Korean dependent parsing are relatively lacking compared to the English language. And more importantly, the natural segmentation, which we call order in Korean, does not correctly reflect either the word boundaries or the morpheme boundaries of Korean sentences, because Korean is basically an agglutinate language that has a lot of morphemes attached to the heads and the roots of the Korean words. In that sense, dependent parsing need to be performed on the morpheme level instead of the word level, or we say the order level. So in this study, we basically equivalent both the order level and the word level and consider them to be same. Anyway, so for those languages which very rich morphology and Korean included, of course. And here comes our proposed format. So the MorphUD format is based on previous work Park and Tice in 2019, which was on morphologic enhanced Korean tree bank format for part speech tagging. And we utilize their format and assign dependency relation to the morphemes rather than the words or orders, the natural segmentation of Korean. And here's an example of our proposed format. So above the sentences is the word-based format based on basically the universal dependency. And you can see the dependency relation assigned to between words. And what we have done is that we add those morpheme level dependency relation to the Korean sentences, such as the dependency relation between morphemes are also included in the tree bank and in the sentence. And in this way, we create a better representation of Korean sentences, which considers the agglutinative features, basically the linguistic features of Korean. And in this way, we believe that it will gain better result and have much more rationales. And in order to do that, we certainly need to convert the word-based format, I mean the universal dependency, to our proposed morpheme-based format. And we provide two scripts to use. Firstly, the word-to-morph script, which as it says, convert the word-based format to the morpheme-based format that we proposed. And then the converted data can be fed to the model for further prediction or dependency parsing. We also provide a morph-to-word format, which is used to convert the morpheme-based format back to the universal dependency, the original format. This is used for evaluation because the morpheme-based format certainly adds more tokens because when words are split to morpheme, certainly has more tokens. And if we compare the morpheme-based result and word-based result, it cannot be fair because the number of tokens are not the same. So we want to use this script to convert the morpheme-based result, prediction back to word-based for fair evaluation. And the root detector is also included to find the root of a word and assign all the dependency relations of other morpheme to the root of the word when we convert the word-based format to the morpheme-based format. And we are employing two parsers, basically the UDPipe as a baseline system and the stanza as one of the trainable state-of-the-art dependency parsers that emerged recently. And as I mentioned before, the data we use include the GSD tree bank and the Kaiser tree bank in Universal Dependencies as the quote-unquote word UD data. And the morph UD data we propose are converted from the GSD and Kaiser tree bank using the word-to-morph script. So here are the results. And as I also said, the word UD output are evaluated as they are, but the morph UD output are converted back to word UD using the morph to word script for fair evaluations. So for UDPipe, we train the model only in each setting. We train the model once and evaluate them. But for standard, because it's a neural model, and we train each of the model 5 times and get the mean of the model and the standard deviations. So in all of the cases included here, we clearly see that the morpheme-based format outperforms the word-based format in terms of the F1LAS score, which shows that our proposed format do work better in a sense that when linguistic features, morphological features are considered, then it certainly enhance the output and our results. And yes, may I also invite Leah for error analysis?
Yeah, so for our error evaluation, we used multival to count the number of left and right distance errors. Based on those numbers, we created the confusion matrix, and you can see that the darker the color, the more errors there are. And so I think next page. So also the most frequent errors for both morph UD and word UD was that we have depth distance 2 errors when they're actually depth 1. So this is a relatively more common feature in Korean because compared to English, which are more right skewed noun phrases, we have more left skewed ones, which are more common. So you can see that the words are modifying immediately preceding words. For conclusion, so in our paper, we proposed our new annotation scheme for universal dependencies for Korean. And the morpheme-based format follows the linguistic properties of Korean and improves our parsing performance. And the conversion scripts are developed, and also the dataset is ready to use on our GitHub. And for related work, we have morpheme-based part of speech tagging, which is the current best one for Korean. And then what's under review is our morpheme-based named entity recognition for Korean. And we're also working on morpheme-based synthetic semantic role-based role labeling for Korean. And thank you for listening to our presentation.